Apache Subversion is a software versioning and revision control system distributed as free software under the Apache license. Developers use Subversion to maintain current and historical versions of files such as source code, web pages, and documentation. Its goal is to be a mostly compatible successor to the widely used concurrent version system. The free software community has used Subversion widely, for example in projects such as Apache Software Foundation, Free Pascal, FreeBSD, GCC, Mono and SourceForge. Google Code also provides Subversion hosting for their free software projects. CodePlex offers access to Subversion as well as to other types of clients. The corporate world has also started to adopt Subversion. A 2007 report by Forrester Research recognized Subversion as the sole leader in the standalone software configuration management category and is a strong performer in the software configuration and change management category. Subversion was created by CodePlex Incorporated in 2000, and is now a top-level Apache project being built and used by a global community of contributors. History: CodePlex founded the Subversion project in 2000 as an effort to write an open-source version control system which operated much like CVS but which fixed the bugs and supplied some features missing in CVS. By 2001, Subversion had advanced sufficiently to host its own source code, and in February 2004, version 1.0 was released. In November 2009, Subversion was accepted into Apache Incubator. This marked the beginning of the process to become a standard top-level Apache project. It became a top-level Apache project on February 17, 2010. Features: commits as true atomic operations. Removed files retain full revision history. The system maintains versioning for directories, renames, and file metadata. Users can move and/or copy entire directory trees very quickly, while retaining full revision history. Versioning of symbolic links. Native support for binary files, with space-efficient binary diff storage. Apache HTTP Server as network server, WebDAV Delta V for protocol. There is also an independent server process called Svn Serve that uses a custom protocol over TCP/IP. Branching is a cheap operation, independent of file size, natively client-to-Euro server, layered library design. Client-server protocol sends diffs in both directions. Costs proportional to change size, not to data size. Parsable output, including XML log output. Free software license to Euro Apache license since the 1.7 release. Prior versions use a derivative of the Apache Software License 1.1. Internationalized program messages. File locking for unmergeable files. Path-based authorization. Language bindings for C, PHP, Python, Perl, Ruby, and Java. Full MIME support. Euro users can view or change the MIME type of each file, with the software knowing which MIME types can have their differences from previous versions shown. Merge tracking. Euro merges between branches will be tracked. This allows automatically merging between branches without telling Subversion what need to be merged. Changer lists to organize commits into commit groups. Repository types. Subversion offers two types of repository storage. Berkeley DB. The original development of Subversion used the Berkeley DB package. Subversion has some limitations with Berkeley DB usage when a program that accesses the database crashes or terminates forcibly. No data loss or corruption occurs, but the repository remains offline while Berkeley DB replays the journal and cleans up any outstanding locks. The safest way to use Subversion with a Berkeley DB repository involves a single server process running as one user. FSFS. In 2004, a new storage subsystem was developed named FSFS. It works faster than the Berkeley DB backend on directories with a large number of files and takes less disk space, due to less logging. Beginning with Subversion 1.2, FSFS became the default data store for new repositories. The etymology of FSFS is based on Subversion's use of the term file system for its repository storage system. FSFS stores its contents directly within the operating system's file system, rather than a structured system like Berkeley DB. Thus, it is a subversion file system atop the file system. Repository access. Access to subversion repositories can take place by local file system or network file system, accessed by client directly. This mode uses the file/path access scheme. WebDAV Delta V using the moddav svn module for Apache 2. This mode uses the HTTP host path access scheme or HTTPS host path for secure connections using SSL. Custom SVN protocol, using plaintext or over TCP/IP. This mode uses either the SVN host path access scheme for unencrypted transport or SVN plus SSH host path scheme for tunneling over SSH. All three means can access both FSFS and Berkeley DB repositories. Any 1x version of a client can work with any 1x server. Newer clients and servers have additional features and performance capabilities, but have fallback support for older client servers. Layers. Internally, a subversion system comprises several libraries arranged as layers. Each performs a specific task and allows developers to create their own tools at the desired level of complexity and specificity. FSAR, the lowest level. It implements the version file system which stores the user data. Reposer, concerned with the repository built up around the file system. It has many helper functions and handles the various hooks that a repository may have, for example scripts that run when an action is performed. Together, FS and repos constitute the file system interface. Moddav SVNA provides WebDAV Delta V access through Apache 2. RAW handles repository access, both local and remote. From this point on, repositories are referred to using URLs, for example. File, for local access, HTTP, host or HTTPS, host for WebDAV access, or SVN, host or SVN plus SSH, host for the SVN protocol. Client, WCA, the highest level. It abstracts repository access and provides common client tasks, such as authenticating users or comparing versions. Subversion clients use the WC library to manage the local working copy. File system. One can view the subversion file system as two-dimensional. Two coordinates are used to unambiguously address file system items: path, revision. Each revision in a subversion file system has its own route, which is used to access contents at that revision. Files are stored as links to the most recent change. Thus a subversion repository is quite compact. The system consumes storage space proportional to the number of changes made, not to the number of revisions. The subversion file system uses transactions to keep changes atomic. A transaction operates on a specified revision of the file system, not necessarily the latest. The transaction has its own route, on which changes are made. It is then either committed and becomes the latest revision, or is aborted. The transaction is actually a long-lived file system object. A client does not need to commit or abort a transaction itself, rather it can also begin a transaction, exit, and then can reopen the transaction and continue using it. Multiple clients can access the same transaction and work together on an atomic change, though no existing clients expose this capability. Properties. One important feature of the subversion file system is properties, symbol name equals value pairs of text. Properties occur on file system entries. These are versioned just like other changes to the file system. Users can add any property they wish, and the subversion client uses a set of properties, which it prefixes with SVN, executable, makes files on Unix-hosted working copies executable. SVN, MIME-type, stores the Internet media type of a file. Affects the handling of diffs and merging. SVN, Ignoria, a list of file name patterns to ignore in a directory. Similar to CVS's ignore file. SVN, Keywords, a list of keywords to substitute into a file when changes are made. The file itself must also reference the keywords as $keyword or $keyword. This is used to maintain certain information in a file without human intervention. The keyword substitution mechanism originates from RCS and from CVS. Svn Specialer makes the client convert end-of-line characters in text files. Used when the working copy is needed with a specific EOL style. Native is commonly used, so that EOLs match the user's OS EOL style. Repositories may require this property on all files to prevent inconsistent line endings, which can cause a problem in itself. Svn External allows parts of other repositories to be automatically checked out into a subdirectory. Svn needs locker specifies that a file is to be checked out with file permissions set to read-only. This is designed for use with the locking mechanism. The read-only permission reminds one to obtain a lock before modifying the file, obtaining a lock makes the file writable, and releasing the lock makes it read-only again. Locks are only enforced during a commit operation. Locks can be used without setting this property. However, that is not recommended, because it introduces the risk of someone modifying a locked file. They will only discover it has been locked when their commit fails. Svn Specialer, this property is not meant to be set or modified directly by users. As of 2010 it is only used for having symbolic links in the repository. When a symbolic link is added to the repository, a file containing the link target is created with this property set. When a Unix-like system checks out this file, the client converts it to a symbolic link. Svn merge info, used to track merge data in Subversion 1.5. This property is automatically maintained by the merge command, and it is not recommended to change its value manually. Subversion also uses properties on revisions themselves. Like the above properties on file system entries, the names are completely arbitrary, with the Subversion client using certain properties prefixed with Svn. However, these properties are not versioned and can be changed later. Svn date, the date and timestamp of a revision. Svn author, the name of the user that submitted the change. Svn logger, the user-supplied description of the change. Branching and tagging. Subversion uses the interfile branching model from Perforce to implement branches and tagging. A branch is a separate line of development. Tagging refers to labeling the repository at a certain point in time so that it can be easily found in the future. In Subversion, the only difference between branches and tags is how they are used. A new branch or tag is set up by using the svn copy command, which should be used in place of the native operating system mechanism. The copied directory is linked to the original in the repository to preserve its history, and the copy takes very little extra space in the repository. All the versions in each branch maintain the history of the file up to the point of the copy, plus any changes made since. One can merge changes back into the trunk or between branches. Limitations and problems. A known problem in Subversion affects the implementation of the file and directory rename operation. As of 2014, Subversion implements the renaming of files and directories as a copy to the new name followed by a delete of the old name. Only the names change, all data relating to the edit history remains the same, and Subversion will still use the old name in older revisions of the tree. However, Subversion may become confused when a move conflicts with edits made elsewhere, both for regular commits and when merging branches. The Subversion 1.5 release addressed some of these scenarios while others remain problematic. The Subversion 1.8 release addressed some of these problems by making moves a first-class operation on the client, but it is still treated as copy plus delete in the repository. As of 2013, Subversion lacks some repository administration and management features. For instance, someone may wish to edit the repository to permanently remove all historical records of certain data. Subversion does not have built-in support to achieve this simply. Subversion stores additional copies of data on the local machine, which can become an issue with very large projects or files, or if developers work on multiple branches simultaneously. In versions prior to 1.7, these SVN directories on the client side could become corrupted by ill-advised user activity like global search replace operations. Starting with version 1.7, Subversion uses a single centralized SVN folder per working area. Subversion does not store the modification times of files. As such, a file checked out of a Subversion repository will have the current date, and a file checked into the repository will have the date of the check-in. This might not always be what is wanted. To mitigate this, third-party tools exist that allow for preserving modification time and other file system metadata. However, giving checked-out files a current date is important as well. This is how tools like Make, will take notice of a changed file for rebuilding it. Subversion uses a centralized revision control model. Ben Collins Sussman, one of the designers of Subversion, believes a centralized model would help prevent insecure programmers from hiding their work from other team members. Some users of version control systems see the centralized model as detrimental. Famously, Linus Torvalds attacked Subversion's model and its developers. While Subversion stores file names as Unicode, it does not specify if precomposition or decomposition is used for certain accented characters. Thus, files added in SVN clients running on some operating systems use decomposition encoding, while clients running on other operating systems use precomposition encoding, with the consequence that those accented characters do not display correctly if the local SVN client is not using the same encoding as the client used to add the files. Subversion tags and branches. Revision numbers are difficult to remember in any version control system. For this reason, most systems offer symbolic tags as user-friendly references to them. Subversion does not have such a feature, and what its documentation recommends to use instead is very different in nature. Instead of implementing tags as references to points in history, Subversion recommends making snapshot copies into a well-known subdirectory in the space of the repository tree. Only a few predefined references are available: head, base, prev and committed. This history-to-space projection has multiple issues. 1. When a snapshot is taken, the system does not assign any special meaning to the name of the tag snapshot. This is the difference between a copy and a reference. The revision is recorded and the snapshot can be accessed by URL. This makes some operations less convenient and others impossible. For instance, a Norway SVN diffr tag 1, tag 2 my file does not work. It is slightly more complicated than that to achieve, requiring the user to know and input URL paths to the snapshots instead of just the names, svn diff URL to tag1, /myfile URL to tag2, /myfile. Other operations like for instance svn logr tag 1, tag 2 myfile are just impossible. 2. When two object types live in the repository tree, a fight to the top can ensue. In other words, it is often difficult to decide at which level to create the tags/subdirectory. 3. Tags, by their conventional definition, are both read-only and lightweight, on the repository and client. Subversion copies are not read-only, and while they are lightweight on the repository, they are incredibly heavyweight on the client. To address such issues, posters on the Subversion mailing lists have suggested a new feature called labels, or aliases. SVN labels would more closely resemble the tags of other systems such as CVS or Git. The fact that Subversion has global revision numbers opens the way to a very simple label revision implementation. Yet as of 2013, no progress has been made and symbolic tags are not in the list of the most wanted features. Development and implementation. CodePlex has continued its involvement with Subversion, but the project runs as an independent open-source community. In November 2009, the project was accepted into the Apache Incubator, aiming to become part of the Apache Software Foundation's efforts. Since March 2010, the project is formally known as Apache Subversion, being a part of the Apache top-level projects. In October 2009, WANDisco announced the hiring of core Subversion committers as the company moved to become a major corporate sponsor of the project. This included Hiram Wright, president of the Subversion Corporation and release manager for the Subversion project since early 2008, who joined the company to lead its open-source team. The Subversion open-source community does not provide binaries, but potential users can download binaries from volunteers. While the Subversion project does not include an official graphical user interface for use with Subversion, third parties have developed a number of different GUIs, along with a wide variety of additional ancillary software. Work announced in 2009 included Subversion J and implementation of the obliterate command, similar to that provided by Perforce. Both of these enhancements were sponsored by WANDisco. The Subversion committers normally have at least one or two new features under active development at any one time. The 1.7 release of Subversion in October 2011 included a streamlined HTTP transport to improve performance and a rewritten working copy library. See also: List of revision control software, comparison of revision control software, comparison of Subversion clients, Tortoise SVN, uBSVN, Visual SVN, Notes. References. Further reading: Dispelling Subversion FUD by Ben Collins Sussman, link broken as of March 7, 2013, external links, official website, previous official site. Not all content has yet been migrated to the new official site. Version Control with Subversion, an O'Reilly book available for free online, Subversion at DMOZ.